Welcome to our presentation on the Center of Parallel Forces and Centers of Mass. This presentation is brought to you by the Mechanics Department of NUBIP, Ukraine. Here are the sources of information used in this presentation, including textbooks and academic publications by renowned authors in the field of theoretical mechanics. Our lecture plan includes topics such as systems of parallel forces, resultant of parallel forces, addition of parallel forces, and various centers of mass. A system of forces where the lines of action are parallel and the resultant vector is not zero is known as a system of parallel forces. To find the resultant of parallel forces, we consider the magnitudes and directions of the forces and apply the principles of vector addition. Adding two parallel forces in the same direction results in a force equal to the sum of their magnitudes. In the opposite direction, it equals the difference of their magnitudes. The center of parallel forces is the point where the resultant of the parallel force system acts, remaining unchanged when all forces are rotated by the same angle. The center of mass of a rigid body is the point through which the line of action of the resultant force of the body's weight passes. For a homogeneous body, the center of mass is determined by the specific weight and volume of each part of the body. For a homogeneous flat body, the center of mass is determined by the area of each part of the body. For a homogeneous thin line, the center of mass is determined by the length of each part of the line. The static moment of an area relative to an axis is a geometric characteristic equal to the product of the area and the distance from the axis to the center of mass. Here are some self-assessment questions to test your understanding of the concepts discussed in this presentation. Thank you for your attention.